All right, hi folks, this is Larry Mussolino. I wanted to record a video here for Module 5, My Lab's homework. This is going to be a part 2 video, so be sure to check out part 1 video that I posted in course announcements. So I wanted to do just a few more examples here from the Module 5 homework. One topic is called implicit differentiation. And what that is referring to is when you have an equation that has a y or a y squared embedded in the equation where it would be difficult to get y by itself. So it's difficult to get y by itself. You can use a method called implicit differentiation. So here, I wouldn't really be able to get y by itself because I'd have to take square roots of both sides and so on. Well, an easier way is to use what's called implicit differentiation. What it means is you're going to take the derivative of each expression on each side of the equation. And then in the end, we're going to try to find dy dx. Now, one thing you're going to have to be careful about is when you take the derivative of y, of a y expression, you must include dy dx due to the chain rule. Because remember, y is a function of x, so dy dx is needed to reflect the chain rule. All right, so let's write down this this equation they're giving us. And let me start out here looking at this 6x squared y. Remember, y is a function of x. Well, I'm going to need the product rule for this because really I'm going to think of it as 6x squared multiplying y. So I'm going to use the product rule. Here's one way to think about the product rule. Call the first expression f, call the second function g, and then we're going to assemble f times g prime plus g times f prime. That's the product rule. So we're labeling the f function as 6x squared. Well, that means f prime is 12x. The g function we're labeling as y, but we need g prime. Well, the derivative of y is just 1, but we have to include a dy dx. So I can write it as 1 times dy dx. All right, let's assemble these pieces. The f function is 6x squared. G prime is dy dx. G is y, and f prime was 12x. All right, let me come over. I'm going to do the same thing here with 5x squared. We need the product rule for this. So I'm going to call the f function 5x, and the g function will be y squared. So let me come off to the side here. F is 5x. That means f prime is just 5. The g function here is y squared. If I take the derivative of y squared, it's going to be 2y. But again, remember, whenever you take the derivative of y, you must include a dy dx with it. All right, let me write down the product rule for this. It's going to be f times g prime plus g times f prime. All right, we need the f function, that's 5x. G prime is 2y dy dx. Right, here's g prime over here. Plus, now we need the g function, that was y squared. And finally, f prime is just a 5. I also have to take the derivative of the right side of this equation, but the derivative of 8, that's the derivative of a constant, that's 0. All right, well, now I do a little bit of algebra because I just want to isolate or get dy dx by itself on the left-hand side. Remember, that's the answer they're looking for, dy dx by itself on the left-hand side. All right, well, to do that, let me subtract this 12xy from both sides. And I'll also subtract this 5y squared from both sides. What I'm trying to do is keep the dy dx terms on the left side. All right, let me write this up here, maybe get a little more space. So here's what we have now. We have 6x squared dy dx This expression got moved to the other side. We have 5 times 2 is 10, so I'll write it as 10xy dy dx. And on the right side, we have negative 12xy minus 5y squared. Well, we want to isolate this dy dx on the left-hand side. So I'm going to factor that out in front of a parenthesis. So I'm going to take dy dx out in front. It leaves me 6x squared plus 10xy. On the right side, we have this negative 12xy minus 5y. Last step, I'm going to divide both sides by this parentheses, because that will get me dy dx by itself. All right, so that cancels top and bottom on the left-hand side. Let me write the final answer underneath. So now we finally have dy dx by itself. So we're ending up with negative 12xy minus 5y over 6x squared plus 10xy. All right, so again, folks, the idea of implicit differentiation, take the derivative in place as you see the equation on both sides. But whenever you take the derivative of y, you must include a dy dx expression as part of the chain rule. All right, let's take a look at another example. All right, this one is going to be similar. It's asking us to find the slope of the curve at the given point. Well, to find the slope of a tangent line, first we're going to need to find dy dx, the derivative. Then we will evaluate dy dx at the given point of 1, 1. 1, 1. All right, let's take this equation they're giving us and use the implicit differentiation method. Remember, our goal is going to be to get dy dx by itself on one side of the equation. All right, let's take the derivative of y to the 9. That's going to be 9y to the 8, but whenever you take the derivative of y, you must include a dy dx due to the chain rule. All right, let's take the derivative here of x to the 9. That's going to be 9x to the 8. Let me come over to the right side. I'm taking the derivative of y. That's 1, but I have to include a dy dx. And finally, the derivative of 4x is just a 4. All right, but I want to get dy dx by itself on one side of this equation. Let's multiply this out here. We'll clean this up a little bit. 6 times 9, that's 54y to the 8 dy dx plus 45x to the 8 equals 7 dy dx plus 4. All right, how about if I subtract? I could either get dy dx to the left side or the right side. How about if I subtract 7 dy dx from both sides? And then I'm going to move this 45x to the 8 over to the right side, so I'll subtract 45x to the 8 from both sides as well. So I'm going to end up with 54y to the 8 dy dx minus 7 dy dx. That's going to equal 4 minus 45x to the 8. So I wanted to collect the dy dx by itself on the left side. Now let me factor out dy dx, just like we did in the example a minute ago. Factor out dy dx. That leaves me 54y to the 8 minus 7. Now I'm going to divide both sides by this parenthesis to get y by itself. All right, so let me come up here. We just found dy dx. All we have to do now is plug in the x and y values that they gave us. So our expression is 4 minus 45x to the 8 over 54y to the 8 minus 7. But we're going to let x equal 1, y equal 1. So in this expression, I'll let x equal 1 and y equal 1. All right, this is going to be 4 minus 45, 1 to the 8th, over 54, 1 to the 8th minus 7. So it looks like that's going to be 4 subtract 45 over 54 subtract 7. So on the top, I think we have a negative 41. On the bottom, we have a 47. So negative 41 over 47 is the slope of the tangent line, or the slope of the curve at that point. All right, so there were 2 steps here. Step 1 was find dy dx. And then step 2 was plug in the x, y value that they gave us, which in this example was 1, 1. All right. Let's see. All right, let's do an example here. So this one is going to ask you to find the derivative of ln x. So there's an ln x here. Well, the derivative of ln x is just 1 over x. Let me also give you a derivative rule that you might need where there's a chain rule aspect to it. What if you have the derivative of ln of some function of x in the parentheses? Well, this derivative would be where you put the function itself on the bottom of the fraction. Its derivative goes on the top. All right, well, let's go ahead and let me write this out. X to the 6 over 6 ln x minus x to the 6 over 36. Well, if you notice the first expression here, we're going to need the product rule. Right? Because it's one function of x multiplying another function of x. So let me label it as f and g. So the f function here is x to the 6 over 6. The g function is ln x. How about f prime? Well, f prime would be 6x to the 5 over 6. But these 6's cancel, so that would just be x to the 5th. How about g prime? Well, the derivative of ln x is 1 over x. All right, let's go ahead and plug into this product rule then. We're going to plug into f times g prime plus g times f prime. All right, our f function is x to the 6 over 6. G prime is 1 over x. The g function is ln x, and f prime is x to the 5. All right, but we still also have to take the derivative of this x to the 6 over 36 back here. So that's going to be 6x to the 5 over 36. All right, let's see if there's anything we can clean up here. Let me erase a little of this to make some more room here. Hold on a second. All right. Let me continue this over here. All right. One thing I'm noticing here in this first, I can cancel out an x top and bottom for that first multiplication. So that's going to be x to the 5 over 6, right? Because this x will cancel one of the x's there, making it x to the 5th, plus ln x, x to the 5, minus, now, this is 6 over 36, so I'll simplify that and just make it x to the 5 over 6. Well, it looks like this is going to cancel. We got an x to the 5 over 6 in front, subtract x to the 5 over 6 in back, those cancel out. So it looks like our final answer here is just x to the 5 ln x. All right. Folks, I think what I'll do here is I'll stop this video, so I don't want to make this too long, and I'll actually record a part 3 with a few more worked out examples. All right, so let me close this out now. Hope this is helpful, and also look for a part 3 video for the Module 5 homework from me. Okay, thanks.